Hello, welcome to the second video this week on hypothesis testing for a binomial distribution. Today we're going to be looking at testing greater than, and we're going to be using critical regions still. We're going to be investigating p-values, which is a slightly quicker way of answering these questions. We'll be studying those in the third lesson, but we'll stick to critical regions for now. So here we have our question. Linda is taking a taxi to work 5 times a week. Over a long period of time, she finds the taxi is late once per week. Okay, so I can model this as a binomial distribution. Okay? It tells us in the question that it can be modeled as a binomial distribution. But the reason I know is because I have 5 trials, the 5 times in the working week, and we have a probability of success of 0.2 because the taxi has been observed to be late once out of the 5 times. So 1 out of 5, 0.2. The taxi firm changes the driver. Linda thinks it's more often late. In the first week, the taxi is late 3 times. You may assume the number of times is distributed binomially, which we have, and we're testing a 5% level of significance to find if there's evidence of an increase in the proportion of times the taxi is late. State your hypotheses clearly. Now, the hypotheses always pick up marks. You need to state those very clearly. So H0, if you remember, is our there's nothing to see here hypothesis, i.e. that the probability is what it says it is that it's 0.2. It's no different. Nothing has changed. Our alternate hypothesis, remember, which is the one that we're testing, and yesterday we observed that it was always testing less than, so something had decreased. Well, today we're going to be testing to see if it's greater than, because there's a couple of sections in the question that allude to this. Linda thinks the taxi is late more often, and then we're testing to see if there is an increase in the proportion of times. So both of those little clues tell us we're testing for a probability greater than 0.2. We have a 5% significance level, and this test is one-tailed. We'll be looking at 2-tailed tests in the 4th lesson in this series. So this value 3 is incredibly important. It's what we're going to be testing against. It's our test statistic. And in the 3rd lesson, so tomorrow, we're going to be looking at ways that we can do this very quickly. But for now, we're going to try to find critical regions. Okay. So firstly, it makes sense to find our expected value of x. If we have a number of trials 5 and a probability of success 0.2, the mean, the expected outcome, is going to be 1, 5 multiplied by 0.2. And actually, you can see that as well from the question. Over a long period of time, she finds the taxi is late once a week. That's the expectation, is it will be late once. And we use that expected value to kind of start our trial and improvement process, if you like. So I can test a couple of different things. I can test probability is x is greater than or equal to 2. I can test probability that x is greater than or equal to 3. I can test that the probability of x is greater than or equal to 4. And I'm looking for the first one of these that's less than 5%. That is going to tell me what my critical region, my critical value, and therefore the critical region is. Now, if you're using the ClassWiz calculator, to do a greater than or equal to probability, you need to subtract from 1. So greater than or equal to 2 is 1 minus less than or equal to 1. Greater than or equal to 3 is 1 minus less than or equal to 2. And greater than or equal to 4 is 1 minus less than or equal to 3. Remember, we would be using a number line to help us identify those. So what I mean by that is if you think of the values 0, 1, 2, 3, 4, if I'm interested in greater than or equal to 2, that's those values over there. So what do I need to do? I need to work out less than or equal to 1 and take it away from 1, and therefore I have my value. So what we can do then is we can type that in. We'll go menu 7, we'll go down to normal CD, and we will put those test statistics in. So we've got, we're going to do 1 minus 0.7373, 4 decimal places. We're going to do 1 minus, just change this to 2. 0.9421 to 4 decimal places, and we're going to do 1 minus 0.9933 4 decimal places, and we'll work those out one by one, and we'll find which one gives us less than 5%. If any of them, if none of them, then we have to keep going. But I think for sure one of these is going to tell us. So we'll do 1 minus 3, 0.2627, which is not less than 5%. Do 1 minus 0.9421, which is 0.0579, which is not less than 5%, and we'll do 1 minus 0.9933, which is 0.0067, which definitely is less than 5%. So we found our critical value. The critical value here is going to be 4, okay, because greater than or equal to 4 is the first probability that returns a value of less than 5%. This is 5.79%, remember, less than 5%. So this is what it has to be in order to be significant. So we say the critical value is that x equals 4, and the critical region is x greater than or equal to 4. And so then we can get to finishing our hypothesis test. So in the first week with the new driver, the taxi is late 3 times. So is 3 times a significant result? No, it's not. Okay, so we've got 3 is less than 4, therefore not in the critical region. Okay, so it's not in the critical region. What are our 2 conclusions? 1, that there is insufficient evidence to reject H0. Remember, conclusion 1 is always whether or not we can reject the null hypothesis. Okay, can that be thrown out, and can the alternate hypothesis be accepted? I always use the language insufficient evidence to reject H0. I always describe it in terms of rejecting H0. And then the second conclusion is the one in context, and we just we put in, say there's no evidence that, and here's where you use the language from the question, remember, so no evidence that there is an increase in the proportion of times the taxi is late. And again, just lifting that language directly from the question. And don't skimp out on this, okay? You need to write full conclusions in order to be sure of every single mark in the question. And I quite often say this is about as close as you'll get to essay writing in A-level maths. So there we have it. We have a critical region for a greater than hypothesis test. So we'll now look at a second example, same as the first, okay? So we've got Brad planting 25 seeds in a greenhouse. He has read a gardening book that the probability of one of these seeds germinating is 0.25. 10 germinated. He claimed the gardening book has underestimated his probability, and so tested the 5% level of significance. So let's first of all, before we get into the ins and outs of is it greater than, is it less than, and all that sort of stuff, let's write down the distribution. So we have a binomial distribution. We have number of trials 25. There are 25 seeds in the greenhouse. The probability of one germinating is 0.25. So we've condensed that sentence into mathematical notation. We know that 10 germinated. That's what we're going to test once we've established what the critical regions are. He claimed the gardening book has underestimated this probability. So let's write down our null and alternate hypotheses. So our null hypothesis, as ever, is that the probability is what it says it is. The alternate hypothesis in this case, right, it says he claimed the book has underestimated this probability. That means he's claiming that the probability is actually greater than what it says it is. Okay? Underestimating it means he thinks it's going to be greater. We're going to test at the 5% significance level again. It's a one-tailed test. Again, we'll get into two-tailed tests in a couple of lessons' time. So the expected value of this, again, is a useful thing to work out. It tells us roughly where to start, and it's especially useful actually when we get to two-tailed tests. So expectation, out of 25 seeds, the probability of germinating is 0.25. You would expect a quarter of those to germinate, all right? So our expected value is going to be 6.25. Okay? How many would you expect? Now I know that that's not a discrete value, but we're just calculating a mean. So the expected value there is 6.25, 25/4. So let's get to testing. It's usually quite a good idea to start one or two either side of the expected value. Okay, in the last question we didn't, because we only had a small number of values that we could test because we only had 5 trials. Now we've got 25. So let's be sensible with this. Let's say we could start with x greater than or equal to 8. That's a couple of values above 6.25. We can also test greater than or equal to 9. We can also test greater than or equal to 10. We can also test greater than or equal to 11. Remember, is this trial an improvement? Now, you might already be thinking, there's a faster way of doing this. Hold on. Next lesson, the third lesson, we will be looking at the faster way of doing this. So, p x is greater than or equal to 8, using the class ways, 1 minus p is less than or equal to 7, for the same reasons as the previous example. So, we'll just do all of these calculations. And again, you can look back to the number line technique in case you're unsure about where I got that 7, 8, 9, 10 from. So we'll go to menu 7, we'll go to binomial CD, we'll go to variable, which is on the class ways. If you've got the CG50, remember you don't have to do the 1 minus part. And the process for getting to that menu is slightly different, but you know it by now. So we've got x is 7, n is 25, and p is 0.25. So we'll do 1 minus 0. We got 7265, 4 decimal places. For the second one here, we'll change our x to 8. We've got 0.8506. And for our next one, we'll change it to 9. Do 1 minus 0.9287. I think we've definitely already hit our critical value, but let's keep going. We'll do 10, 0.9703. And let's work those out. Go back to menu 1 and start our calculations. 1 minus 0.7265. 0.2735. And we'll do 1 minus 0.856. We get 0.1494. Again, all these to 4 decimal places. We'll do 1 minus 0.9287. 0.0713. We hadn't already got to our value, so then 1 minus 0.9703. 0.0297. Now, if we hadn't hit upon a value that was less than 5%, we keep going. All right. Now, in this instance, we've hit upon our value on the very last one, and we've got greater than or equal to 11. So what does that mean for our hypothesis test? So the first probability that we got that was under 5%, and that's what we were looking for, was when x was equal to 11. So the critical value is x equals 11. So the critical region is x greater than or equal to 11, i.e. if we did this test, we'd be looking for 11 or higher in order to return a significant result. So let's look at the test. We've got the fact that 10 of Brad's seeds germinated. So 10, unfortunately, is less than 11. So therefore, it's not in the critical region. Remember, if it is in the critical region, unfortunately, both of my examples aren't. I suppose that's a bit of a bad choice, but never mind. If it is in the critical region, then it is significant. If it's not in the critical region, then it is not significant. So there's insufficient evidence to reject H0. And 2, what does it mean in the context of the question? It means that there's no evidence that the gardening book underestimated the probability. And like I said earlier, don't skimp on this. Full explanation. There we go. Now, that's it. That's how to find the critical region for an upper test. You know, combining that with the lesson that we did yesterday, by the end of this session, you should be absolutely fantastic at finding your critical regions. And then tomorrow, I'll show you a quicker way of calculating probabilities. All right, many thanks for listening. Take care.